Okay, so hello everyone. Welcome to our afternoon session of Open Security Summit 2020. We are all excited to be here, and I hope you too. What we expect your participation, of course, mutual respect, care deeply, and just learn from each other. In our summit, we really respect openness, so sessions will be video recorded and even sometimes live streamed. This one is not live streamed yet, but there are other sessions which have live streaming. All the content will be shared then in YouTube and in our official summit website. If you don't want to identify it, you can just take some personal precautions, and that is up to you. So we here just respect each other, collaborate with each other, try to help each other, and try to have some life scenarios that will be really very useful then in your companies. And also we want to learn from you. If you can bring your experience, that will be also very great. So thank you very much for coming, and please share your views in tweet us, and just be generous with sharing everything just in LinkedIn or any other social media. I will share the links in the chat just after this. Thank you, and I'm giving the floor to our speakers. So. Elvin.
Thank you very much. So I guess in this particular session, we're basically going to pick up from where we left off in the last one. And in the last one, we were basically trying to identify how we could extract information or data from the ISG specifications, those requirements, into a form that we can programmatically then utilize that information, as well as how we could also sort of generate test data to verify against those ISGs. So I think that a few of us have actually carried out some experiments on how we can potentially do this, and there's some demos to show for it. So I guess I'll hand over to Vinh to kind of kickstart that.
Thank you, Elvin. So I'm just about to share my screen. Okay. Are you guys able to see my screen?
Yes.
Okay, so following from what we was discussing in the last meeting, we was trying to figure out, based on looking at one of the NSA's documents on PNG, ISG, sorry, documents on PNG, we was trying to figure out how we can programmatically extract all this useful information on the risk and recommendations. So I've never done this before, but having a look on the web and just trying to see what tools are available, I came across this one, which is quite interesting, called Textricator, if that's pronounced correctly. Gives some quite useful quick starts, but interestingly, the main three sub-command options is being able to pull out data from forms, tables, and text. Here's something I tried earlier. So this particular quick start is looking at a PDF, and it's in a table format. And what they've managed to do is you can actually extract the information as CSVs, like so, or you can even spit it out into JSON. And so looking at this, it looks quite feasible. But what I was interested in was this one, because it seemed like it's something useful for us. And playing about this, I was quite interested to see what we could generate from basically running this on our example PNG one, and the result I got was we can extract the information from the PNG one, and it seems to pull out every bit of text.
Sorry, Vinh, if you're showing us something we can't see.
Oh, sorry, hang on a second. Maybe there's... Can you see my screen now?
We can see your screen, but not what you're showing us. I mean, right now we...
If you've got two monitors, we can probably see one and not the other.
I've only got one, so somehow I've done it wrong. What about that one? You seen it now? Can you see my JSON file?
Yes.
Yeah, got it.
So this is the JSON file that's been generated by parsing that ISG document. So I don't know if you can see the ISG document in front of me.
No.
No. Okay. It seems like I have to keep flicking. Ultimately,
I think if you just sort of roll down from that, that looks to me like it's disassembled the sort of down to the PDF content, doesn't it?
yeah. So what I was interested in seeing was how much of the if we look at the PNG document itself, when I did a search on the risk and recommendations down here, there seem to be about 12 of these.
Yeah, can you latch on one of those and see
Yes.
what we get after that?
So let me just share my flick to the other screen. So what I quick did as out of interest was I just wrote a quick noddy little C# program to just consume that JSON file that was generated by that tool. And if I run it, you can see we are able to pick out 12 risks and recommendations.
You can't see anything, Vin. You just see your code.
Are you not? What screen are you seeing?
Just your sample code at the moment.
I think you need to sort out what we can see because it's very difficult. You say you just got one monitor.
Yeah.
Well, I'm seeing part of the monitor.
Hang on a second.
I think what's happening is you're able to share particular things, not your actual. If you don't want to see your screen.
I think you selected an app rather than the whole screen.
Yeah, you should have selected the whole screen by the sound of it. Yeah.
Okay, hang on a second.
You should say something like screen 1 or something.
Screen. Okay. How about that?
Yeah, that's better.
Better?
Yeah, that's a lot better.
Okay. So basically, I've just knocked out a quick .NET C# app, console app, and consuming that, you can see that it's read in all the 9,346 of the JSON items. And if I just did a simple link query on that and just pulled out the recommendations, it does tally up to the number of risk and recommendations on that PDF. So in essence, that's as far as I've got, but...
Can you show us the JSON again, sort of from one of those lines, and actually see how the content looks when you're...
So basically, there's the actual JSON content that's been produced, and if I hover over one of the number of risk, obviously the items that are ready are really raw at the moment, but it's picking out every word basically.
Yeah, I mean this program obviously goes right down to the
But
guts of
this
the
may
PDF
be
document.
something useful for us to be able to look into further. It's not the friendliest way to.
No, I think it's possible. I've certainly come across other tools that break things down in PDF into, you know, paragraphs and sections and tables in a more sort of friendly way.
Yeah. So
but it could be a useful base.
Yeah. So it's built on something called let me see, where is it? PDF box. So I don't know if you can actually bypass this extricator and actually go straight into this using this as a thing, but that's where I got to.
That's interesting, Vin, because I was also playing around with a few of these tools, and I had something that produced something similar to what you've got right now.
Okay, shall I flick over to you then?
Yeah, I could share my screen, go through that. You guys see that?
Yep.
Cool. Hopefully I'm not just sharing an app, so can you see my notepad as well?
Yep.
Yep.
Cool. So yeah, so the tool I was using,
No,
let's see if I,
did you pull it up?
Sorry?
Yeah, it's good.
Okay, cool. Yeah, so the tool I was using is actually called PDF to JSON. It's a little JavaScript module that I found on GitHub. So I haven't actually got the page open right now. But basically, it also provides you with a command line interface, which meant that I could quickly run a couple of sort of tests and examples of what it can do. And the output that I actually got was also similar to yours, Vin, where it was JSON, and it seemed to go down to the actual text snippets and provide you with sort of the coordinates for each snippet of text. But that I found that would be quite tricky to utilize, because it means you have to figure out a way to amalgamate all that text together to form something useful. And then I kept on reading, and they mentioned something about extracting it as pure raw text, which I did, and that came up this way, which seems to be the entire document, all the text from that actual document. And I thought that this would actually be quite useful. So I did do a search for risks and recommendations, and you can see that you've actually got all of them outlined below. You don't have any of the formatting, but you do have all that actual content. So we can actually grab it all. And using this with some regular expressions, I don't see why we can't produce a file in any format, only kind of capturing the parts that we're actually interested in. So I found this to be quite useful. So it gives you both modes. You can grab the JSON in this form, or you can just grab all the raw text if you want to.
Well, this looks a bit better than the one I've got, because mine was far too granular.
So what I was actually hoping, but unfortunately I didn't have the time, was to actually combine this with what Steven's done, and I'll let him share that with you guys in a second. And that's the generation of test data. I was going to create a sort of a simple JSON file and try and figure out how I can map the two together. So go from JSON to actually running a test. So I'd have predefined sets of files with a specific set. So in this case, I probably pick the PNG header example, for instance, and generate the file for it, run a test, and kind of populate the same sort of JSON file to show you that that's the actual result, whether it passed or failed, etc. So I was hoping to get there, but unfortunately didn't have enough time to do that. So that's kind of where I stopped. So before we actually carry on, I think to get a kind of overall a good picture of it all, it'd be useful for Stephen to actually kind of share what he's done so far.
Yeah, yeah, certainly. A few different things. Something else I've just been looking at just now. I just want to.
So I'll hand that over to you, Steve.
Yep. Okay. Let me just sort out. Let's see if I can make sure I share the right thing. Screen number one. Screen number one, please. I've pressed the button. Nothing happened. Oh, there we go. Right. Okay. See risks and recommendations at the top. Is that visible to everybody?
Yeah.
Yep. Okay. So I was looking at one thing was on our actual cameras, doing a little experiment to see how well we could use Glasswall itself to do a bit of construction of manipulated files. This is purely for sort of testing purposes. So here, for example, I've taken a small PNG file. I then ran it through our export mode, and that produces a report and log and what have you, and in there's a zip file. I also enabled the full disassembly of image files, because our default is to actually just output image files in our export packages as their raw format. So this is a fully expanded export file in XML for the PNG file that you could see in the other window. Now, what I then did is I created a modified version of it. So if I open these two directories up in good old Beyond Compare, they've hang on, it's lying to me. Right, okay, slight confusion there. Yes, I took that original export directory, copied it, called it modified, and I've made a copy of the zip file and made that the modified one. So actually what I should have done, go into the modified directory. Right, so there's two zip files in there, the original one and the modified one. So if I compare those, you'll see there's two XML files inside there. And I went in and I edited, did a little copy and paste. So I simply took that PLTE chunk, which I think is probably at the start. I think I'm sure it's the first structure in there. Okay, I'm not going to find it now. Let's try searching for it just to show you where it is. So it starts up there, and then I've made a complete copy of that structure in the XML file. I didn't do anything else with it than that. That may not be particularly valid. Well, I don't think it's meant to be valid at all. I think that was one of the first things that was the reason I did it, because I saw it mentioned in the ISG file for it that that was only ever meant to be one of those, and copied it across and then made that container file. So if I go back to here, I now have two zip files, and I then ran it back through Glasswall, re-imported it, and that still has got validation on. I'll tell you why that was in a minute. What I wanted to try and do was disable validation, which I did put a switch in and proved that if I disabled validation, it would still try and produce a file. But then there's a secondary check that we have when we try and write data back, that we've proved that we have actually visited every node in our tree. Therefore, that needs to be disabled as well, and that's why I couldn't get that to work. But what this shows usefully is in the report, when it tried to import that, bingo, it threw up a fault from our callback code saying only one PLTE chunk allowed. So clearly, as expected, we've gone through our specifications and we've put in rules that follow all the little rules and regulations, and it's spotted that that imported file doesn't validate properly because that extra chunk is in there that shouldn't be there. Now, if I got the loop right where I'd get the right to allow us to write out the corrupted file, I would expect us to, when we process a file with that corruption in, that you would have that same effect. This is sort of proving that at that point, when the re-import works, it's actually already running the validation on a fully reconstructed file with the mistake in it and throwing up the validation in there. So I'm quite happy that that will actually, once I get the other right validation, the right check disabled, that you'll actually be able to output a file with that specific fault in it, and therefore add it to your archive of specifically modified files. So that sort of, I think, comfortably proves that, as we'd expect, we can use our export-import formats to construct modified files. Now, there was a little discussion earlier today. Let me find that we were talking about what sorts of things we could make use of. So this came out of that we could use this mechanism to generate sample data based on rules from the ISG specifications. In order to be able to test whether we actually match one of these rules, we can actually use this as a potential mechanism for constructing, maybe programmatically, different tests and different faults. You could also potentially use the regression tester to help assist that validation. But there's a question mark about whether we need to necessarily even go that far if we can highlight those changes. Now, that came from something else.
Could you just expand on what regression tester is first?
Oh, I'm sorry.
That's not possible.
Yes, we have a tool built in-house that carries out testing on our cameras, on our system by taking a version of our software, taking a whole suite of test files and a suite of YAML files that identify what to expect before and after, well, probably maybe just after. So it will take a file that we've got a known issue in, a known piece of data that should be present that indicates that there was some container that shouldn't be there, or there is something in our report that would indicate too many of a particular item is present. We run it through the regression tester will run that test file through, and then we'll look at that YAML file that tells it what to look for in the output file to confirm that the necessary change and fix actually occurred. And that will be able to give us a pass or fail for that proof that our camera or our system carried out the necessary test, and that can be then run on hundreds or thousands of files, either against the same test sets expecting the same types of faults, or various different ones depending on what's been built. This lends itself very nicely to doing these ISG tests, because we could construct a whole suite of files with the specific types of faults that are being looked for, make sure our system deals with them and flags up that it's actually done that particular correction or rejected the file or remedied it or whatever. The regression tester will know how to look for the different types of warnings, the different types of reports, and the different types of data that we specifically say that test file should have or shouldn't have, depending on what we're actually correcting. Now, the other thing on here was a couple of ideas on what we can use or how we can use the ISG data. We could use it to do a sort of an external testing suite. So we could potentially take our system, take some test files, put them through it, and have some external code a system that checks against those. And potentially that might be where the regression tester is used, but we need some tool to take these validation statements and produce the necessarily test files. So if we can find something to assist us in automating the job of building this whole suite of test data and test scripts, that's one possible route. Another thing is our own internal validation data and callback code that does validation is likely to already do a lot of the things. For example, the little one I just showed you was an example of one of the ISG validations that was saying that particular chunk should only exist once. When I duplicated it, we already threw out an error of that nature. It is quite likely that we could use that perhaps to create an additional suite of tests that are named against their ISG equivalents. Or maybe another third option is we simply do a review and actually find all these various tests and put an initial bit of extra tag against them to say, when you throw up that particular error or that fault that we've already identified as belonging also in the ISG specifications, we could put some sort of tag on there to say, if you throw up that DVL, that data validation test, or that callback code, when it reports, it'll have some additional tag on it to say this belongs with, or this relates to a specific ISG specification and the particular piece of validation or change that it's recommending. Therefore, we could then have a report filter that puts that into a subsection of our analysis reports when on demand to cross-check to those ISGs. So that may be one of the simplest solutions, that we simply make use of what we've already got, put some additional data in to say this particular sanitization ID or this particular test belongs in that set as well. And that will potentially make it easiest to carry out some sort of automated correlation between the test sets from the ISG specifications, what we already produce, again, using obviously some test data that needs to go in to prove these things. But that may be one approach that reduces the amount of change or the amount of work that we need to do, and then effectively puts this ISG compliance testing in permanently within our system that you can choose to filter out as a reported sequence of information if you need it. And with the regression tester, we can run those particular tests against our defined set of ISG setup data files that have got those particular issues in. Now, there's one just little thing I just noticed, though. We were talking about how we do. How we might select and grab this data. There's one thing that just jumps out at me here, and I've seen various things. It may not be as simple as we hope. We've got very clear our data validation language. Perhaps if I just bring up an example of that. Very much takes particular identifiable structures within a file and lists a series of tests to be applied to values. Interestingly, I just noticed there CRCs, we don't actually, it would seem, do checks against those. So that's the sort of thing where these reports have point things out. Sorry, I just want one thing, but we got stuff like this, like the validate chunk types, find a specification on the whitelist. Those are quite broad, so it's not just a simple case of that's a one-to-one mapping. That's the sort of thing that we are potentially picking up by a lot of our structural reading, for example. So you're going to, Vinh, was that you say something?
Yes, it's Vinh. I was just about to say, just backtrack to a couple of meetings back. I think we do CRC checking in the rebuild, but not in our editor.
Right. Okay. So that's cool. That's the sort of thing that we need. That's useful to pick up on the things that rebuild is done by sort of hand created code.
And I suppose doing these ISG checks, at least on the rebuild, we can see where we've missed it out when we've gone and on to call to rebuild. Editor. Yes,
that is a good point. That if the testing is done as an external thing, that can be run against rebuild and editor. So yeah, that's a good point. But I was simply sort of, we were having discussions earlier, trying to find ways to reduce the amount of work that we need to do. But that is a good point, actually. And, right. Okay, that was all I had for the moment on that. I was just
cool. Yeah,
just knowing my endpoint security is just pinged up and I can't seem to find my phone to reassign it.
Do you know what's so hilarious?
What's that?
I thought it was my endpoint, and I've been trying to look for it to close it.
Don't.
Yeah, that's actually pretty interesting, Stephen, and it's good that it actually kind of. theoretically it should work. Basically, based on what you've shown, there's no reason why we shouldn't be able to generate test data with specific corruptions that we can then sort of publish in that repository and everyone has access to, etc. And obviously, you mentioned that some of these rules don't lend themselves to sort of just one-to-one mapping, so you can't validate one thing against the other. In some cases, one-to-many, right? But the next question I have is can you hear me?
I can hear.
Okay, cool.
Yeah, hello. Yeah, sorry, it's that VPN when it reboots, it seems to cut us off the network briefly. So yeah, so I caught back into that. You were saying about how some of these don't map. Yeah. Well, they map to a broader set of tests, and I think this was something that the discussions were coming up the other day, that we were sort of getting a bit sort of concerned that there was this suggestion that these are the Bibles, and we certainly do a lot of stuff, but maybe we do things slightly differently, maybe more verbosely in some places, maybe not in others. But it's certainly a massively worthwhile exercise, but it's try to but to do it as efficiently as possible and as broadly as possible.
But isn't this, as I view it, two things going on? I think the first thing is on our Summit ISG, what we're trying to generate is the requirements JSON to pull this out as rules for anyone to consume. And then we've got this other one, which is going on internally for ourselves to be able to prove that we do meet those ISG recommendations on that requirements JSON.
Yes, but there could be crossover where we could take advantage of some of this data to assist us in those validations. But I take your point that both Rebuild and Editor kind of want to be validated externally or cross-checked in some way. I think it's just yeah. I'm just sort of concerned that if we start building a huge suite of disassembly mechanisms and test data and whatever, and test rules that duplicate a lot of stuff we've already got, that always seems a bit of a shame to do that, because it becomes more to maintain. Whereas if we can borrow things we've already got in some way, that seems a more efficient way of doing things.
Yep. Fair point. But just to get back on course for this session, and the idea was that we kind of move the needle slightly from the last meeting, in that we were originally trying to identify how we can extract information, and I think with sort of the initial experiments we've carried out, and there's probably better ways to do this stuff, but it's definitely doable, and something that we could at least have a first cut fairly quickly. I think, Stephen, with what you've done, you've also proven that we should be able to generate test files with those specific ISG issues in them to allow us to then verify against it.
Yes.
The question now is how can we join those two together to actually form a sort of test suite, a test framework? How can we generate a test framework from that? So right now we've got the ability to let's assume that we've got the ability to generate those test files, and we've also got the ability to extract them and have them in a JSON format, for instance. What do we do with it from then?
I guess, I mean, the thing that was jumping out of me, it was how well we can use it, whether we can do very automated work. I guess it's the case of if we can get the JSON data to sort of formulate a database of these various tests that are where we can find similarities between them and potentially identify ones that very easily translate into some things that you can test, then you've got the option to sort of automate those. And then you have the problem that some that are not so easy to map to something instantly, they then obviously need some sort of human input to them. But maybe that's done as a sort of as a series of transitions, that we take the things that we can see some automated mechanism and produce something from those that are some sort of rule sets that are easy to sort of automate from, and then and then what's left over needs sort of manual effort to create the necessary scripts or extra details in that next stage of extraction that then gives you a series of tests that you can process. I'm wondering if this is sort of where we need to sort of look for some sort of useful sort of framework, whether this is a job for some sort of testing script environment that's easy to use, or even just
looking at. Sorry, I was looking at Yara and looking at how it can actually.
You got some examples of that?
Of Yara?
Yep.
Yeah. Well, the repo is over on. Actually, I posted it to the Slack. You can put. Let's see. Yeah, if you want to head over there and just maybe take a quick look at it, see what you think. But it's been used for all kinds of different types of pattern matching, and if you're looking for patterns, whether it's one way or the other, it would probably be good to be able to pass it through something like that and make it so much easier. Then all you have to do is worry about. Hold on, let me see.
Do you want to share your screen?
I actually can't share my screen at the moment, but
okay. You say you pinged a link on.
Yeah, it's on the Slack.
Which?
I actually put 3
channel?
links on there. Here, let me drop it in the chat. All right. There we go.
Yes, here in the chat there is the
Got
link.
It.
So
got it.
Perfect.
Come on there.
This may make that part of it a little bit easier. Sorry, I'm moving to the other room so you don't hear my background noise.
It's okay, no problem.
I'm not familiar with this, so anyone wants to walk me through it.
The link that you're looking at here shows different projects that use Yara, and it basically does pattern matching. So you can set certain rules and have it match according to those rules. It'd be easy enough to take the things that that you're looking at and working with, put them in here, and then all you have to do from there is basically figure out repackaging them as a file with those sections removed that that you want to have removed or altered, however. And you could even go into zip files with yextend and put that on there too.
This seems to be an appropriate area to look. I think.
And there are all kinds of different ways that people have used it, and it's been used by, I mean, a lot of different. Yeah, you can see the list right there on the awesome one, whatever it is. Let's see but it's filed. Or wait, sorry. Hold on, let me pull it back up.
Yeah, I mean they seem quite simplistic things, perhaps not good examples to.
But it would kind of remove the need for breaking it down into something simpler, taking the PDF and making it into something like, I mean, you would still, I guess, have to do that to make the rules if you wanted to simplify making the rules. But then if you put them into that, the only thing that would pretty much be left would be repackaging it according to the rules. And I mean, it's not that complicated from there. You have an extended however many file types, so you don't have to go over every file type individually yourselves. It's already kind of set up to do that. Does that make sense?
Yeah, I'm just curious as to sort of what sort of level this goes to.
So just to clarify,
you dealt with this?
Sorry, are you speaking to me, Stephen?
Yes. Sorry, Elvin.
No, vaguely familiar with it. But just to clarify, basically, this would allow you to basically define all the rules that we've got for those ISGs. Obviously, we've got our generated test files. That's a separate thing. But this then lets you plot every single one of those rules, and you can then utilize this to verify whether the existence of a particular element or items present or not, or what, depending on what your rule is. Is that correct?
Correct.
Cool. So, Stephen, I guess a good way to visualize it is probably a more sophisticated version of the regression tester.
Well, it looks like the sort of thing you might want to plug into your regression tester, isn't it? Because I think that's got sort of some search facilities, isn't it? But this looks like something that would be a useful sort of thing to bolt in there to be able to add more detailed rules like this. I'm guessing this is sort of able to sort of hunt through, looking for whole suites of different tags and identifiers within a file, and then come back with a result saying if these are there in a particular order or a particular way.
Right, and it is rather powerful. There are other things that people could use with it in sort of a modular fashion if they want as well, depending on how you set it up.
Yep,
you'd have to sort of spend a fair bit of time writing a whole bunch of different regular expressions and things, probably, and gluing them together to get a similar effect.
I'm thinking that we possibly won't be able to avoid that anyway. Just to generate for instance, the data itself, you would have to know what corruption you've got to make and go through and modify all those bits accordingly anyway. The same thing would apply to verification. So if you're going to verify that, if you're going to write rules to verify that whether you've sort of cleaned a particular area or whether you match a particular condition, you'd still have to manually go in and insert those rules. So the steps that we kind of get for free at the moment is just the extraction of data from the PDF document, and the fact that we've got something that will actually generate that data for us as well. But the actual creation would actually have to be manual. I don't think I'm struggling to think of how we.
Yeah, I mean this is sort of doing sort of test searches and things, isn't it? We want something you can actually give some sort of meaningful series of instructions to say, take this file, put this stuff into it, do that to it, make these changes.
Well, and
it starts becoming a program as such, really, doesn't it?
Mm-hmm. In a sense, that's kind of the thing, though, is it allows you to be able to actually use. So if you look, where is it? Let's see. I have to pull up the. If you look on the Yara, so it's awesome Yara, that one.
Yeah.
There is a way that you can actually, and I'm not suggesting using this, but there's an idea that I think you could take from it and use it more directly than this. But there is let's see, it's in services.
I noticed it saying inspired by Awesome Python, Awesome PHP, suggesting it's sort of built around. And this reminds me of some things where I've done in the past where I've used, for example, a Python tool called Scones, which was a build tool that allowed you to do build files, but then where there was custom bits, you could just drop regular Python in to deal with edge cases. I'm wondering if this is...
So there is a way to actually more easily put in the rules. So let's see, like Yara, the Yara editor under services. Here, I can get that pulled up for you and send it to you.
Oh, well, this one here.
This is just, I am not suggesting using this.
Oh, do you want to share
I
you got your?
it's, I just sent it over.
Oh.
I'm not suggesting using it, but I'm suggesting that perhaps it might give you an idea of something that would be useful. And the reason I say I'm not suggesting using it is I don't know if you want to take the time really to have to put everything up in this sort of way. But they have an editor where you can edit the rules rather simply and easily. So instead of having to rewrite everything, right, having to do all of them and go through all of them by scratch, you're editing it using something of an easier platform. But if you set it up on your end for a back end, that allows you to adjust things the way you want, I mean, it might work out better for you. I don't know, just a thought,
I think from what I was saying, Elvin was saying we probably, if this has got more sort of capabilities to allow you to construct things and control things, then that may well be useful. It's difficult to quickly grasp what capabilities this has.
It's going to take a little bit.
Yeah. I mean, the validation stuff sounds, quite useful.
And then just
I think we'd have to do a bit of. But I think yes, trying to find a way of capturing the rule creation and validation in some sort of succinct way, either partially automatically and partially hand edited. Using some available tooling would be perhaps a very valuable thing to be able to do.
I mean, it's been used by everything from. It's been used by everything from like virus total to video triage. The forensics video triage with autopsy. So there are a lot of different places that end up using it in a lot of different ways. So I definitely think would be something that would be worth it to look over and see what you can do with.
Completely agree. I think it's definitely worth exploring.
Something there with a Python plugin, the looks of it.
Yeah.
Yes, I think probably a long explore actually with that to see what capabilities it's got. Maybe it is something where creating some additional plugin rules and functions and things that suit what we're doing. Maybe we do extend it into something that we could use.
I'm actually interested in listening to Matthew's opinion on this stuff because he's playing around with quite a lot of our testing stuff. So I don't know if he's got any insight into this.
Being honest, I'm deliberately keeping quiet on this. Basically, anything that gets done can easily be built into my environments. Anything that runs on a Docker container will run for me. So it's not a problem in that regard.
Okay. Cool. Any other suggestions on how we can kind of sort of automate this process? So I'm actually struggling to think of ideas, to be quite honest.
I think we go. Whoops, where's the? I love menus that come down in your way.
I think it'd be useful to have someone like Dennis in a session like this, to be quite honest, as well. Yeah.
I did have one of the specs somewhere. It must be on the screen. Hang on. Yeah, there it goes. Yeah, I suppose it's a case of sort of looking at some of these things and seeing how these look like things that you could automate tests from. Because they're quite wordy, it all depends on how rigorous these descriptions are, and I think we were saying this the other day, but if these form very neat, clear descriptions, there may well be things that you can automate tests from, but it depends.
It's like, look at number 4. That sounds a bit wishy-washy. Chunks are found in acceptable locations.
Well, in the specification, yeah. You see, that's a bit like the other one I picked out on. They are very useful statements, but they, in a sense, are a broad description for a massive series of tests that likelihood, we'd cover a lot of. I mean, in that particular case, that would, that particular case are PDD definitions that describe the structure of the file. Acts as a schema that would probably fix that, would probably deal with that by its nature, because that will expect things to be in certain places in certain orders as per specification. So bingo, that probably drops out of that. But how do you prove and test that necessarily? I mean, you can clearly, you could build a series of tests that prove, oh, I've put chunk X in the wrong place, bingo, our system drops it out. But that's not something that I could see any automated system being able to grab that and go, yep, I know what to do. Something like this, yes, maybe you could, but there is I think the trouble is these are very nice, but I think they're very human. I think they need a lot of human effort to come up with definitive tests. I
mean, if you can break them down into like a and or nor zor like type thing.
It's all what, sorry?
The and or nor XOR, you can break it down into that, then it would be a little bit easier to see. So like the number 4 there, chunks are found in acceptable locations. Well, you're gonna have to determine what acceptable locations are for a specific type of chunk. And then, well, I mean, to figure that out, you're gonna have to think about what the chunk is you're working with. I mean, you're looking at assembly, right? So, or the binary. So you're gonna have to look at where it's supposed to be,
yes,
or where it's not supposed to be, and then think and or nor or zor, right? So you take it and you put it. Is it supposed to be here? Is it supposed to be here? If it's here, is it supposed to be here too? If it's not, whatever. Like you put it in each of those categories. That's what you're gonna have to be looking for. It's gonna be quite a process, but that's something that you kind of have to think about if you're trying to set it up like that. And honestly, if the machine, yeah, I don't know. Anyway, but that's good.
Well, we're looking at trying how to validate this. I mean, our product is designed to do this sort of thing. I mean, that particular example we're talking about, we can look at our definitions here. I mean, since the whole specs out in the world, it probably doesn't matter wholly. But so, for example, this is a sort of group of definitions here that's telling you what chunks are allowed in a certain place. So that you've got, a file header, that chunk is only allowed there once. These ones are allowed in any order in that place. That one is allowed there. These ones are allowed optionally in this place. So, and then this end chunk is only allowed, well, it's optional, but has to be at the end. So that's the sort of mechanisms we have to define these types of requirements. Where it is. So that, I feel, would address that particular statement, because we've built that code from, or that data definition from the specification based on where it says things are meant to be. And if anything's not
to the specification, doesn't it?
Yes. So therefore, sorry, go on, Martin.
No, I'm going to say it says according to the specification, and that's exactly how the DVL has been created, from the specification. So tick box. Yes.
It's a case of, how you write a proof of this is somewhat tricky. It's kind of, well, you could build a whole suite of different dummy files that have got chunks in the wrong place as proofs in those particular cases. But I think broad proofs of software, I know, is an area of computer science that can get quite convoluted and difficult to deal with. But obviously, we don't really want.
In what way do you mean proofs?
Well, getting into sort of absolute proofs that all possible conditions of fault are dealt with. How many possible ways could you rearrange the chunks to be wrong? Clearly billions. So, yeah. So you can't prove 100%. You can only go, well, we looked at the spec. This is our version of the spec data. That is a definition that says it follows it. So
use predicate calculus and the development method.
Yeah.
Mathematically prove it. And you get into those sort of realms, aren't you?
But from sort of testing stuff I've worked in the past, this is the sort of thing where you would potentially create a series of, like I say, partially broken things that are clearly incorrect as far as the spec's concerned for that particular rule, and prove that it works by running it through our system, going, yep, we put that chunk, it's not meant to be there, it gets thrown out. 2 more in the other places, yep, they get thrown out. But that's what I'm getting at, is that these sorts of definitions are very are nice definitions, but they're nice and broad. They are things that you could create a series of tests for that sort of generally prove them to be dealt with. But you can't expect any nice, easy, automated test to come out of that.
That test is almost a headline for a set of subtests.
Yes. Yes, it is.
So it's not just a test, it's saying chunks are found in acceptable locations, and then you have to have a sub list there saying how you would test each of those. I mean, others are pretty much easier. You've got there 5, validate, can't really read that because there's an arrow in the way, but S something, sRGB and ICCP chunks are not both present. That's fair.
Yeah, see, that's a nice logical one that potentially you could do with the scripting that we were just looking at.
Yeah.
That potentially, so if there's a marker for both of those that's easy to see, you could say if this marker and that marker is present in the file. The other one, I suppose possibly if you could potentially go by ordering, maybe. You could go ordering of chunks if there are identifiers in there, and you could say, you could look at the order.
But this is not something that can be automated.
I don't. Yeah, not easily.
What about something like a generative adversarial network working on something like this?
You have to explain that one to me.
Because then it would be continuously testing itself. And it would have to learn from a sample set to be able to test it and make the other one like it, just to kind of.
Yeah, you still got to create samples then with the suitable errors in.
Well, let's be honest, that can't be avoided.
Yeah,
it's going to have to be something, but at least that way, humans aren't having to do all the heavy lifting.
I mean, I feel obliged to remind you the first rule of testing is that exhaustive testing is impossible.
Well, yeah, that's kind of what that number 4 sort of dropped out, really, isn't it? It's that sort of thing. Some things, yeah. I mean, those 2 are a perfect sort of example, aren't they? That you can absolutely do a perfect test for, because you can say that one is present, that's not present. It's a binary test. You can prove all those out. That one clearly to make a perfect proof of.
If you want. Sorry, go ahead.
No, I was going to say you can't positively prove number 4. You can only do enough of a sample to say, as far as we can see, sort of saturation test, if you like, whatever, it passes, but we can't have a finite number of tests that would satisfy that because of the permutations, perhaps.
Well, if you could break down a file into chunks and ensure that that file has every chunk, then you could programmatically shuffle all those chunks around to get every permutation of them, I suppose.
Yes,
how much value there would be in that, I'm not sure. But
I mean, in fact, out of those, number 3 actually is quite straightforward in principle. That all those defined not to appear multiple times don't. That can be easily done. You just find all the ones that shouldn't appear multiple times and then put them in multiple times in each test.
Yeah, I think.
So it's kind of not black and white, is it?
Yeah, I think one thing something Elvin was mentioning about sort of trying to reduce things to their bare minimums of small items. I mean, it does sort of make me wonder about. I mean, it sort of goes back to using Miroplast, the tool chain we've used in the past for evaluating and creating. Well, we've not really used it much for creating data, but that's one of its mechanisms. Whether we could create an interface into our import-export mechanism to simplify the job of creating structures from sort of raw class names and structures and the data you want in them. Such that you could produce small, not necessarily 100% valid files, but snippets that will pass and show but fail for the particular reason you want them to fail, as a way of validating.
Stephen, I think you've actually just answered that. You've just solved that problem because you a second ago you'd gone through a PNG file and sort of demonstrated those chunks. So if you've got a definition like that and you've got a DVL like that and you've got the tool set, so example Miroplast for instance, and as you suggest, you can just take that particular section of it. You're just verifying that particular section. It doesn't have to be a complete definition, but you could utilize Miroplast to verify that it's in that particular sequence.
Yes, because you may then be able to sort of script something. I mean, we could potentially make a front end to it to allow us to script it more more easily, just sort of literally some sort of ultimately maybe literally a JSON file where you say, right, I want one of these, 2 of these, 3 of those underneath it, with the bare minimum data in them. You might not even be interested in necessarily populating all the data, but sort of really sort of a subset of that sort of that XML that we're using. In fact, maybe that is an approach we need to do, because the XMLs we've got are still a little bit too large and wordy and too many tags and details in. If we can try and refine them a bit and simplify the job of constructing them, or like I say, using Miroplast itself in a similar sort of way, such you have a nice, simple, wordy description of the key elements of the file that you're interested in, and have it build that from that. That could be an approach, and that would allow us to describe the minimum you need to push it through the camera to say, right, does this look like a valid file with this bit in it? And you'll go, no, it's got that's fine, but this bit's wrong, and that's what you're looking for. So yeah, maybe that's an approach. It's a sort of, I suppose it's a bit like a unit testing sort of approach, isn't it, where you're only testing the bare minimum that you need to test.
Mm-hmm. That's definitely a good point, Stephen. Yeah, and of course Miroplast, it's got its SDK, so it's programmable. So
exactly, we've never really stretched it very far. We built a few tools around it, but yeah, one of its initial mechanisms was that you can write code to create a complete file from scratch, similar to like the programming framework that comes with Office, where you can construct files both binary and XML ones, I think.
Mm-hmm.
You can programmatically say, start a document, put in 2 pieces of text, and this. Obviously, that will always produce you nice, perfect files. So that's not useful necessarily for this testing, but yeah, Mirror Plus, it certainly will take a structure, and if you say put things in the wrong order, it's not really going to stop you, I don't think. No.
Well, I mean, this is quite specific to PNG, but one of the things I did do was when I was using Tweak PNG, you can create a PNG file using Tweak PNG and create very bare minimal PNG files that can break some of these rules.
Right.
But again, that's not really useful. It's very specific to Tweak PNG. PNG itself. But what we do want is more something like we used to talking about Mirror Placid, which is more
general, isn't it?
Yeah, it's more general.
It's interesting. Cool. Any more suggestions, ideas, thoughts?
I was just thinking that if we could make a standardized way of changing the language, that would really simplify things. I was actually thinking about looking up to see if anyone had done that.
Do you mean for the ISGs?
Yeah, of taking language and using, I guess, phrases, but not like as complicated of phrases as what are shown on there, but something that we could take those and break them down into, like for instance how XOR is able to take a more complicated idea. It's not that much more complicated, but it's still more complicated than and or nor. Just take something and how can we break it down into so that the language actually has a meaning composed of those things, so we can actually use a description. Like I don't know how to explain what I'm trying to say without actually putting something together.
Are you suggesting something quite formal, like Bacchus-Nor form?
I think it would be good. I think it would be good. That way, like, it would actually be useful for something like, a neural network to be able to take this language and, parse things into different categories based on something that is a little bit more advanced, perhaps, than basically, yeah, taking the language and although you're making it simpler, it's more complex than the language that has been able to be used so far without it being an actual coding language. So instead of like chunks are found in acceptable locations according to specification, being able to take that and break it down into something that would be usable and understandable, because chances are a certain language in here is going to be repeated over and over again throughout the ISGs. I don't know how to even explain what it is I'm trying to say without.
I think you're talking about some sort of domain specific language that then translates from sort of a very legalese description into something else.
Yeah, but not necessarily legalese. Like a programming language, for instance. There are different ways of being able to actually make things simpler, but to take it directly from the language versus having it be programming. Do you understand what I mean? So yes. You don't have to rewrite and reprogram things over and over again, but it can actually take it directly from the language and turn it into something it can run on or something it can use. I think that would be That would be awesome.
That sounds like a bit like the BDD, which is a declarative language of sorts, but it's more a declarative structure that then code is built from, which is a form of DSL really.
I'm actually Paul Burke. Are you on this call?
I am indeed, Elvin.
Cool, because I've actually got a question for you. It's regarding the ISGs. How much do you know about them in terms of how they created and generated, etc.?
Not nearly enough is the answer. I can provide very little insight like you. I've been playing catch up with this stuff.
So I'm actually wondering, for someone like Boyd, obviously he has to create these things, and he's probably already got a predefined sets of data, etc. They've had to go through this stuff, right? And yeah. I'm actually curious. It could actually give us a big shortcut if we could get access to some of that stuff.
Yeah, I wonder though whether these were just written by a bunch of experts getting together and pouring through the standard and using just little bits of sample files to go, that looks dangerous. So I don't know whether they'll have a structured data set that we can use, but we can certainly ask him.
I think it's worth asking, definitely.
Just out of interest, I was thinking about what Matt was saying about rearranging the chunks and getting a finite set. Actually, can you hear me? Am I?
Yeah, we can hear you.
Oh, sorry. Yeah, I was just thinking about the mathematics of that, and I mean, I don't know how many chunks are in ping, for example, but if you had say 10 chunks in there and you wanted to test all the permutations of that, you're talking about 3,628,800 different permutations just for 10 chunks. So it increases very, very quickly the more sort of data you are actually trying to rearrange here. So you have to think in terms of just taking a subset of that 3 million and saying we've done enough tests here, we think this works.
Yeah, I think I'd have to agree with you there, Martin. For some of this, we'll just take it for what it is. There's certain things that we're just not going to be able to maybe even we won't even be able to validate some of these, and that's okay, right? Because you'll have something against that saying that look, it's not possible to get validation in this programmatically or whatever, but and that's fine. It's actually about getting as much coverage as we possibly can, right?
I did open with exhaustive testing is impossible as well, remember?
Yeah.
Everything is just best effort.
Yep.
To risk mitigation.
Well, no, you said that, but then we did say that, for example, 3 could probably be finitely tested and 5 certainly. That's easy.
Yeah, that's one tiny part of this massive whole.
Oh, yes, but I think that just shows how varied all of these are from 1 to 9 in this example here. How varied, where we've got finite, which we can test, and then we've got rather vague sort of spec that says, it has to be in this order, and then we've got others that, if they don't appear multiple times, so it's a different gradation really of the tests. It's a sort of good example actually.
And perhaps one of the first exercises you go through once you've extracted all the content from here is to actually go through each one of those and identify which ones can actually be tested and which ones can't. So you kind of put a label against the ones that you're going to skip over and then start focusing on that, I suppose.
Well, yes, that's interesting because you could actually do grade them as I've just said and we've just been discussing. Say this can be definitively tested. It's either this is either present or it's not. Or this is duplicated or it's not, etc. And those are finite, and you can flag those as saying we can actually test those absolutely and give you a definitive answer to say it passes or fails. Whereas others, as you say, we can't do that. We have to say we have to take a sample and say we're satisfied. So I think there's sort of different categories, as you're saying, Elvin, to these. I think that's a start, was to decide on those categories.
Yeah. So can all this stuff be used to effectively improve risk scoring files?
That's actually a very interesting question.
Yes, that's what I was thinking as well. Yeah, because you're taking a risk by saying, there's so many permutations, we can't do them all, but we can test X number. But then that is a risk.
It's not only that, it's also looking at the ISG as a whole and saying that depending on your coverage against this, that could kind of suggest the sort of risk level. So if you've sanitized a document, for instance, and you've covered, say, all the testable parts of this, for example, you could actually say that this is fairly low risk because we've been able to deal with all these points that are mentioned in the ISGs.
Yeah.
I think that's definitely possible, Paul.
Yeah.
I think
it's Vinh here, Paul. I think I'm not sure if he was on the last meeting just before stand up. I've just pinged you a Google Doc that Dennis shared with us, and there was some talk about the risk management on some of this ISG stuff.
Cool. All right.
And if you click on that, you'll see this. There was some definition of facts on page slide 3, where we were discussing the risk mitigations and the risks of files, and on slide 4, I think that sort of answers your question about level risks.
Yeah.
Yep.
Got it. Risk of files. Yeah.
Yeah. So I guess you're thinking of this as in sort of improving that sort of threat sensor side of things. Is that correct, Paul?
Yeah, I'm just thinking about progressing on what has gone into the forensic workbench right now, and making that whole risk assessment a more granular thing than, hey, we just found some certain, very limited types of active content. It gives you a whole lot more that you can apply risk scoring to it.
I think once you got to a point where you've actually got at least the majority of this, or at least some part of this automated, then there's no reason why that can't easily be done. In fact, I think it'll be quite a trivial exercise if you've got all the automation around it.
Yeah. Cool.
Cool. Anything else anyone would like to add? So I think we're kind of sort of running out of ideas now.
Well, I think we've covered quite a lot, actually.
We have. It's been very interesting, and I think from our side, the guys at Glasswall, we're definitely going to pursue some of these suggestions and see where we get with that.
How do I get to information on perhaps the previous session which I was at? Are there any supporting materials placed anywhere in particular, like the slides, etc., that Vinh was talking about?
Well, I've just discovered. I'm new to Zoom as well, and I've just recently discovered you can save the stuff in chat. So I'm hoping that once the Zoom session goes, I'll be able to still have the links to all the stuff that's been put in our chat for this session.
Yes, that's.
We will. After this session, we will have a recording of the session published in the website, and also in our YouTube channel, and all information will be again placed in the website. You can find it in the session. There should be all the links.
On the website.
It might be worth also taking some of that content, if applicable, and adding it to the GitHub repository. So, for instance, the presentation you're talking about, Vinh.
Yes.
On the bottom right of the chat, you can do save chat. I suppose that's each person independently doing that themselves.
Are we finished with this session? Maybe it's a good time to stop the recording, because I think we're diverting off the point.
I just got one thing about Mirror Placid, if anybody wants to sort of look at the example of that, if that's relevant to the code generation side of things, because we were talking about using that tool. Do you want to reference that here, or do you want to discuss that elsewhere?
I think you can go for it, Stephen.
Yeah, I mean, I was just sort of digging around and found, I was pretty sure there was some samples in the SDK for it that actually constructed a file from scratch within it. I couldn't quite find which one it was, but this one here showed an example of it. Now, obviously, this is quite a lot of extra noise with C# involved. But what I noticed there fundamentally that this particular one brings in a BDD definition for a bitmap file, and then and there actually constructs a new one, which it then starts to populate with different nodes. Down here we can start. They've commented it. There's the. I was wrapping it around oddly. Yeah, so there's
you've got quick view. You've got
yes,
quick view. Yeah. That's very short.
Anyway, there's enough here to see. So there's talking about here, it's creating a new structure, it's creating a bitmap header, and it's simply populating those nodes that it expects to have particular values in. So it does occur to me that that is something that you could potentially create, like you say, maybe a JSON file or something or something similar that you define that you want a bitmap. So there's the name of the header, and then what the name of the elements or the structural elements you want to construct. There's not a lot of naming there. That's maybe where it'll be a slight problem. But it is quite. I'm trying to see if there's anything there that tells you what it's creating. No, it's very much value based, isn't it? It's kind of, it does seem to be assuming that you know the structure. So yeah, it's possible that it'll be usable or something from it. I'm not quite sure. Might have to look again at the structures it creates. But it certainly had. I certainly recall it having named elements within the BDD. So possibly maybe a way of creating something that uses the text of the BDD to allow you to create a structure of named elements that you want and what fields you want populated. Say the other alternatives, we use our own import framework, but I think this one might have less overhead on it, but there's certainly the facility to construct a file from scratch or a snippet thereof. Okay. So yes, maybe we can make use of this framework somehow to do that sort of tool, but that's a research project in itself, I think.
Oh well, I think you've probably volunteered yourself for a little
experiment. Yeah, sounds that way, doesn't it,
Stephen? The point of it, the way I see it, is if we carry out these small experiments, even if they're not the complete thing, it kind of gives us confidence that we can actually move it forward, and it's actually certain things actually doable, and we kind of eliminate other ideas, and sort of come to a point where we've got a solid set of tools that we can potentially use to actually get what we're trying to achieve.
Yes.
Cool. I think that's everything.
So if there is no comments, questions, really very impressive and productive discussion. Thank you everyone for joining, and I think Dennis will be very happy, and he will feel bad that he was not in the session, but probably he will request new session, so you will need to do it.
He can watch the video, can't he?
Yeah, so thank you again.